In logistics engineering, and really in any kind of data-driven decision-making, it's essential to understand the difference between data and information. It may sound like semantics, but it's not. Let's start with data. Data are raw, unstructured. They are the basic recordings of events, signals, or states, like sensor logs, scanned barcodes, or timestamps on a pick list. They don't tell us much by themselves. A list of numbers, a stream of positions, a series of time entries, these are just symbols. There's no meaning attached to them yet. The tables you pull from a WMS or ERP system, that's data. Now contrast that with information. Information emerges when data are processed, when we organize them, analyze them, and relate them to a context. Only then do they become useful. Information allows us to draw conclusions, make decisions, or take action. Information contains meaning, implication, or input for action. Information enables decisions. It is the outcome of interpreting data in a meaningful way. To turn data into information, we need structure. We need to process the data, analyze it, often clean it, and above all, interpret it in the right context. Context is what transforms a measurement into a message. Take this example. You might have picking timestamps, but unless you know when the picker started, how long the route was, or what kind of order it was, those timestamps tell you nothing. And that's even the case for metrics like a picking rate. You cannot simply compare picking rates in warehouses across companies. In one company, staff might be picking small items with a range of 1,000 SKUs. In a second company, they might pick furniture with a range of 50,000 SKUs. A meaningful comparison of the picking rate without having this context is not possible. And here's something subtle but important. Very different information can come from the same data set, depending on what we analyze, how we filter, or what question we ask. The same raw data can support completely different conclusions. The same data presented in different contexts can lead to very different information. This brings us to the role of indicators. First of all, what are indicators and how are they different from metrics? A metric is a quantitative measure used to assess, compare, and track performance or behavior. Metrics are generally numerical, objective, and are calculated based on data. They often have defined formulas. A metric becomes an indicator when it is used to signal performance relative to a target, norm, or threshold. Indicators are interpreted values that provide insight into whether something is going well or not, i.e., they have diagnostic or prescriptive meaning. Indicators are metrics we use to convey information. Picking rate, UPH, throughput per hour. But they only have meaning if we know how they were measured, under what conditions, and with which assumptions. Indicators are built from metrics, but they only become indicators when they are tied to performance interpretation. That is, when they reflect whether a process is achieving its goals under given assumptions and targets. You could also say a metric is like a thermometer reading. It tells you the temperature. An indicator is when you interpret that temperature as fever or normal, based on a medical threshold. All indicators are based on metrics, but not all metrics are indicators. Let me illustrate. Saying the average picking time is 45 seconds is a metric. Saying the average picking time exceeds our target of 40 seconds and thereby flagging a problem, that's an indicator. And therefore, the purpose of indicators is not simply to report numbers, but to convey meaning. They provide performance feedback that supports decisions. This is also why context is essential. A picking rate of 150 units per hour might be considered excellent in one warehouse and poor in another. depending on the layout, item mix, or automation level. And the same applies to UPH or units per hour. It is not comparable across environments unless all assumptions, such as process design, workload type, and measurement method, are aligned. Otherwise, we end up comparing apples to oranges and making flawed decisions based on invalid comparisons.